Howdy everyone. Today we're going to talk about section 9.2, which is on special right triangles. Special right triangles is a topic that you are going to see pop up again and again and again in your math career. We're going to talk about it in geometry. It'll be back in Algebra 2, and you'll visit it again in pre-calculus and calculus. So what I'd really love to have happen is I'd love for you to get really great at them right now, so that the next time you see it, you'll just think it's easy, and it won't be something that you have to relearn again over and over and over again. So the two special right triangles that we are going to talk about are some very popular triangles. They are right triangles, and so they will have 90-degree angles, but they'll also have some other special angle measures. This triangle right here is a special right triangle because it has a 30-degree angle and a 60-degree angle as well, and this triangle shows up in a lot of places. You will find it all throughout your home and all throughout your life. Our second special right triangle is this one right here, which is going to be having not only a 90-degree angle, but also having 45-degree angles as well. And this one I think is even more popular. These two triangles are the most popular kinds of triangles that you see. Okay, so here's what we're going to be doing. What we're going to do is we're going to be taking a look at some of these triangles, and one of them is called the 30, 60, 90 triangle. And what I have right here is I've got some side lengths that are labeled on here. And these are very all short side and simple sided figures right here. So I have a side length of 1, a side length of 2, and a side length of square root of 3. Now down here, what I have is I have a whole bunch of other 30, 60, 90 triangles. And basically what I'm going to do is I'm going to use the connections between both of these triangles in order to find any missing side lengths that I don't have down here. So what is that connection between them? Well, if you take a look right here, it says all triangles we see today in this lesson are going to be similar triangles. And they're similar triangles because they have matching angles. Remember that we have a similarity theorem that is called the angle-angle, or if you'd like, the angle-angle-angle theorem. And it says that if you have two matching angles, then that means your triangles are similar. And that means that all of your angles are going to be congruent and all of your side lengths are proportional. And that's the part that we're really going to focus on. I can definitely see that if I look at any two of these triangles, that they have matching angles. I can find those matching angles very quickly and very easily, but it is the side lengths that are going to change. And so we're going to be looking at some triangles that might be a little bit bigger or a little bit smaller than this picture right here. And we're going to see if we can figure out what those side lengths are. So let's give it a shot. Right here, what I want to do is I want to see if I can find the values of the variables. And so I've got an x right over here and I've got a y right over there. And when we find these values, we want to find them as exact values. No decimals, please. Okay, so if I want to start with these guys, I can find them in any order I'd like. I can find whatever side I'd want. I'm going to choose to start with x because I'm boring like that. X right here is the side that I'm interested in. So I want to make sure for my proportion that I include it. So I'm going to put my x in there. Another important thing to do when you're creating a proportion is you want to involve any other sides that you are very aware of, side lengths that are known. And so that is going to be 2 right here. I'm going to use the 2 as well. Okay, so now what I'm going to do is I'm going to take this triangle and I'm going to compare it back to my original one that I have right over here. And the way that I'm going to do is by pulling the same kinds of sides. X right here is the hypotenuse. It's opposite of the 90-degree angle. And so I want to reach over here and find that same type of hypotenuse over here. And that is going to be a 2. Then over here, the 2 that I had pulled right here was a leg. And not only is it a leg, but it's the shortest one. And so I'm going to compare it against my shortest leg right up here, which is going to be a 1. Okay, now we're going to do what we always do. We're going to cross multiply and simplify. So x times 1 is going to give me x, and then 2 times 2 is going to give me a value of 4. And that's it. We now know that this hypotenuse right here has a length of 4. All right, we have a y value that we need to find as well. And we're going to do basically the same kind of thing. I'm going to start by building a proportion, and I want to use my variable y, and I also want to use any known side lengths. So I could use the 2. I could also use the 4 that I came up with, but I'm going to be conservative, and I'm going to choose the values that are printed on the page because I know that they're correct and that there wasn't any errors that were created when I was finding those values. Okay, so now what have I done right here? When I create my fraction of y over 2, I use my medium length side and my short side. And so when I reach up here, I want to do the same exact kind of thing. I want to use my medium length side and my short side. So that is going to be root 3 over 1. I'm going to cross multiply again. Y times 1 is y. And 2 root 3. Now 2 root 3 is going to be 2 different kinds of numbers, one that does not have a radical and one that does. So you're not going to be writing down any 6s, but rather you're just going to write down the 2 values next to each other. 2 root 3. Oops. And there you go. Now we've got our values for our 2 side lengths that we didn't know before. Let's try another one. So now this one right here has got another x and y combination. We're going to see if we can solve those. The only difference right here is that the places where they're located at. So last time, the side that I knew about was my shortest side. This time, the side that I know about is my hypotenuse. Let's see how if it changes our technique at all. So for our x right here, once again, we're going to start off with our x variable and any known side that we have. So it's going to be x over 10. Okay, so now what did I use? Well, x was my medium length side and 10 was my hypotenuse. So when I come up here, I want to do the same thing, medium length side, which is going to be root 3, and then my hypotenuse, which is going to be 2. Cross multiply. This time what's going to happen is I'm going to do 2 times x, and I'm also going to do 10 times root 3. Okay, so now that's not done yet. So we need to get our x variable alone. We need to get rid of that 2, so we're going to divide. And that's going to give us an x value. 10 divided by 2, these numbers are both outside the radical, so you can reduce them. 10 divided by 2 is 5. And don't forget about your square root of 3, so we'll have that root 3 there as well. X is equal to 5 root 3. Let's do the same kind of thing for y. So y is going to start off with its own special ratio using the value of y and any printed value of 10. You could use the 5 root 3 if you wanted, although I don't think I'd recommend it. And we need to determine what we've got. So y was our shortest side and 10 was our hypotenuse. So when we come up here, we want to once again use our shortest side and our hypotenuse. So that's going to be 1 over 2. And we want to cross multiply. Y times 2 is going to be 2y. And 10 times 1 is going to be 10. Once again, our y variable is not alone, so we're going to need to divide a little bit, and that'll give us a y value of 5. Okay, it's at this part where some students might start to tease out their own tricks that they might be noticing. And so a lot of times the trick that some people might notice is the relationship between their shortest side and their longest side. There is definitely something that is happening here that relates these two numbers, that's going to relate these two numbers, and is going to relate these two numbers. And if you've come up with a pattern for that right now, then you can use that. That's totally fine. You don't always have to set up a proportion in order to make them work. Other people might notice relationships between their shortest side and their medium length side. Another way to write this medium length side might be to write it like this. And then what you might do is you might start noticing similarities between these guys right here and between these guys right here. And if you start to notice those tricks, you can definitely use them. You don't always have to set up a proportion. I like to use proportions because that's what we were doing in some of our earlier chapters that we just finished up. And also they work. They work really, really nicely, and they'll never falter or change. They just work great every time. Let's try a couple more. If you want to use your trick, you can. And if you want to follow along with my proportions, you're more than welcome to do that. To begin with right here, I'm going to start with my variable and my known side, which is going to be my x over 8. Now that is a short side and a medium length side. These are my two legs. So I'm going to use the same kind of information right here. I'm going to use my 1 and my root 3. Now what you're going to see with this one, even though the setup is very much the same, when we start cross multiplying, it's going to get a little bit worse. We're going to have this x root 3 right here, which is not going to be great. And then we're going to have on our other diagonal, we're just going to have an 8. Okay, now to get our x alone right here, I'm going to have to divide by the square root of 3. And when I do that, I'm going to get a not so great fraction, which is going to be x is equal to 8 over the square root of 3. Now that fraction is not too bad. The numbers aren't very huge, but there is a square root in it and it's in the denominator. Now, as we learned in the past, that's not okay. You can't have a square root in the denominator. So we're going to do something called rationalizing it. We're going to multiply the top and bottom by the square root of 3. And when you do that, you're going to get your final value for x. Up here in the numerator, 8 times the square root of 3. Those numbers are not very similar, so we can't do much with them. Down here in the denominator, a square root of 3 times another square root of 3. That's a really great pattern, and hopefully one you're starting to feel really comfortable with. Root 3 times root 3 is 3. This fraction right here is about as nice as we can make it. We can't simplify it or make it any better than that. So 8 root 3 over 3 is going to be our very best answer for our x value. Now for y, we're going to go down some similar path. What we want to do is we're going to use our variable and our known side. So we're going to use our y and our 8. And then we want to set up a second ratio with the same kind of information from our other triangle. When I chose y, it was the hypotenuse, and when I chose 8, it was the medium. Hypotenuse over medium means we're going to do 2 over root 3. There you go. And I'm going to cross multiply. Once again, y times root 3. And then 8 times 2 is going to give me 16. I'm going to have to divide by the square root of 3. And once again, this is something I have to do, but I'm not really thrilled about it because I'm going to have a square root down in the denominator. I don't really love that idea. And the reason I don't love it is because I'm going to have to rationalize it. So I'm going to multiply by the square root of 3 on top and on bottom. And when I do that, my numerator, there's not a lot I can do. Well, I have a number that's outside the radical and one that is underneath the radical, so they're just going to kind of be next to each other. And in the denominator, root 3 times root 3 is hopefully something you're starting to get really fast at. Root 3 times root 3 is 3. And once again, maybe if you're starting to develop your own patterns right here, you'll notice that there's a lot of similarity between the two answers that we come up with, but there's only one big difference. And it happens to be the exact same difference you'll see in some of the other problems that we've seen so far as well. Let's do our last problem right here. I'm going to start off with my x variable and my printed value. What have I chosen? I've chosen my medium length side and my shortest side. So when I come up here to my top triangle, I want to once again use my medium and my shortest. So it's going to be root 3 over 1. And I'm going to cross multiply. X times 1 is going to be x. And here's an interesting one. We're going to see 2 root 3 times another root 3. Because there are so many root 3's and they're being multiplied, we're going to use that same pattern we saw before. 2 root 3 times root 3 is going to give us equal to 2 times just 3. And that means our x value for this problem is going to be 6. This is a real surprise for a lot of people because we start off with a number that is maybe not so great, and we end up with one that is so very satisfying. Y variable right here. Maybe once again, you've got a nice shortcut to get you that y value very quickly, and that's fantastic. Otherwise, you can use your proportion, which I promise you is also extremely quick. Our y value is going to be plugged over our 2 root 3 again. And when I'm doing this, that's the hypotenuse over the shortest side. And I come up here, I'm going to use the hypotenuse over the shortest side. That's going to be 2 over 1. Cross multiply on my diagonals. Y times 1 is going to be y. And 2 root 3 times another 2. Now, even though they're in the front and the back, we have a number that is outside the radical and another number that is outside the radical, and they're being multiplied. So you can put them together. 2 times 2 is 4. And so we'll end up with y is equal to 4. And we still have that square root of 3 right there, which hasn't gone anywhere or changed in any way. And so we're going to make sure we include him as part of the answer and not forget him. Okay, how about some you try it problems? There are 3 problems down here at the bottom of the page, and I'd like you to try those out now. You might want to pause the video. Here are some answers for your you try it problems. Got some x values of 6 and a y value of 12, an x value of 4 and a y value of 4 root 3. And over here for your x value, you're going to get a fraction of 18 root 3 over 3, which reduces down to 6 root 3. And you have a y value of 12 root 3. For all of these, hopefully maybe you can start to, once again, make some of those connections for some of those quick patterns. There are patterns that relate these numbers. There are patterns that relate these numbers. And there are patterns that relate these numbers as well. Okay, so now this is one of our 2 special right triangles. This is the 30, 60, 90. Our second special right triangle that we're going to be talking about is our 45, 45, 90 triangle. For this one right here, once again, I think that this one's a little bit more popular. And the other really great thing about the 45, 45, 90 triangle is I think it's a little bit easier to work with. So we saved the best one for last. For this 45, 45, 90 triangle, one of the reasons why I think it is so great is because not only does it have a set of matching angles, and that we have 2 45-degree angles, but it also has a matching set of side lengths. We have 2 side lengths right here that are both the same. And I've marked that by using the exact same number 1, but I've also used that by marking it with these tick marks right here. That's a really, really great and kind of obvious trick right there. And so when you see a situation like this, where you're trying to find any missing side lengths, I have a missing side length right over here, and I don't need to do any work for it. All I need to do is just remember that my side lengths or my legs should match each time. And so I'm just going to bring that 6 right over. And so that's super fast and easy, and that won't change for any kind of 45, 45, 90 triangle. Okay, so now the other piece that we need to find is we need to find our hypotenuse right down here. So when we're looking for our hypotenuse, I can call it x. And I'm going to set up my proportion just like I have before on the other page. And when I've done this basically the hypotenuse over one of the legs. It doesn't matter which leg, it's just one of the legs. And so I want to see if I can set up the same kind of thing over here. Once again, hypotenuse over one of the legs. I'm going to multiply on my diagonals. That's going to give me an x is equal to 6 root 2. A lot of times when people are working on these kinds of problems, they'll start to notice some of those same kind of patterns are going to bleed through from the last page as well. For the second problem right here, once again, you'll notice you've got the legs that are a match set, so you don't have to find both of them or even one of them. And then we just need to see if we can find that hypotenuse. So we're going to do that. I'm going to set up my ratio as x over 4 root 2. And I'm going to set that equal to the same kind of ratio for my top triangle right up here. When I set this up, that was hypotenuse over leg, and I'm going to do the same thing, hypotenuse over leg. And I'm going to cross multiply. X times 1 is going to give me just x. and then 4 root 2 times root 2. This is not the first time that we've seen this pattern, but it is just going to keep on showing up. A root 2 times a root 2 is a 2. Now, that's not the only thing that's going on here. We also have that 4, so don't forget about that. And these two pieces are being multiplied by each other. So that's going to end up giving us an x value that is very satisfying. That's going to be an x value of 8. Last one right here starts off with the hypotenuse, and you can definitely see that the legs are going to be the identical value, which means we don't need to solve for each of them individually, but rather just once. And I'm going to set this up as x over 12 root 2. Now, when I've done this, I've set this up as leg over hypotenuse. And so when I set it equal to my second ratio, I want to do the same thing, leg over hypotenuse. So that's going to be 1 over root 2. I want you to notice that that's a little bit different from what I've done for the last two. I did the root 2 on top the last couple times. I'm going to multiply on my diagonals, and when I do that, I'm going to actually end up with x root 2 is equal to 12 root 2. Now you can see that we've got a couple of root 2's, and in this case right here, we're going to end up dividing by root 2, and that's actually great. In this situation right here, our fraction is starting to look a little bit worse, but remember that root 2 over root 2 is the same as 1 over 1, or 5 over 5, or 18 over 18, or 1,000 over 1,000. It's always going to be a big and fancy looking, but also extremely boring special case of the number 1. Ones don't really do so much for us. Dividing by 1 or multiplying by 1 isn't really going to be very exciting. And so because of that, that's just going to basically be 12 times 1, which is just 12. So our x value for this problem is going to be 12. All right, now what you have is you've got a couple of you try it problems. If you want to pause the video and try those out, that would be fantastic. Here are your you try problems right here. We're having some side lengths that are going to match, or some leg lengths, I should say, that are going to match, and you're going to end up with a leg length of 9. You have a hypotenuse right here, which is very closely related to our legs, and that's going to be a value of 4. And then once again, you've got another hypotenuse with a couple of legs, and those are going to be 4 root 2. Okay, so now we've seen two different kinds of triangles. We've got our 30, 60, 90 triangle, and we've also got our 45, 45, 90 triangle. In your homework today, what you're going to end up with is you're going to end up with some questions that are 45, 45, 90 triangles and some that are 30, 60, 90 triangles. The other important thing that I want you to do is I want you to make sure that you can flip-flop between using both of these, because they're both in your homework assignment at the same time. When we were doing the notes, we just focused on one triangle at a time, but in your practice, there will be both. If you have any questions about that, by all means, feel free to reach out during class or send an email. And otherwise, feel free to rewatch this video if you would like.